Hey, hello everyone. In this video, we will be solving the day 21 of March Leetcoding challenge, which says a reordering power of 2. So let's check the question. So starting with the positive integer x, n, we reorder the digits in any order such that any of the leading digit is not 0. Okay. So we have to return true if and only if we can do this in a way such that the resulting number is a power of 2. So let us check this number. So this is a power of 2. 10, if you reverse it, it is 0 1, which is not a valid answer. 16 is a power of 2. 24 is not a power of 2. 46, its permutation is 64, and that is a power of 2. Okay, so let me just explain the question. So let us say if we have this number with us, right? 281. So what are the different permutations of it? So one of the different permutations are 218 itself, 218, 281. This is one of the permutation. 218 is one of the permutation. 812 is another permutation. 821 is another. 128 is one of the permutation, and 182. So if we check all these permutations, we can find that this permutation is a power of true, right? And that's how we say that for this particular input the output would be true, because one of its permutation, that is 128, is a power of 2. So how exactly we can do this? Like, there are different approaches to solve this. One of the approach would be basically the input number which we have given to us, right? What we can do is that we can just count the frequencies at which index, like how many, like 2 is present, 8 is present here, and 1 is present, right? So if that information somehow we could mold it and then check how exactly we can get it, right? So 281. So what we can do is that we can do 10 raised to 2, that is 100. 10 raised to 8, that is 10 raised to 8, this one, and 10 raised to 1, that is 10. So this is the hash which I have created right now. I am adding all this thing, and this is the resultant which I have. So after that, what I will be doing is that for every power of 2, I will again calculate the same hash. And if any time, if I get the hash as equal to the result which I have already pre-computed, I can say that uh, we have found one particular permutation which is a power of true. And else, if that's not the case, we can say that there is no such permutation which is a power of true. I think the major important thing to understand here is basically the input which we have given to us, right? Somehow we have to calculate a hash of it, a hash function of it, and then for every power of 2, we will again calculate the hash function, and we will check that hash function to the pre-computed hash value which we have got. So let us check the code now. So it will be more clear now. So this is the first thing. There is a method called as count frequency, which will basically uh, calculate the this result. Basically, it's a hash function. So here, what am I doing is that for every modulus operation, I'm doing a modulus operation on n. So initially, it would be 1, and 10 raised to 1, that is 10. So 10 would be added to frequency, and now my n is divided by 10. So now 281 becomes 28. So it is again greater than 0, so it will loop on, and that is how this frequency is calculated, and that is what is returned. So now the hash is at my result, and then uh, I am basically trying to find all the permutations of, like, basically I'm trying to find all the powers of 2 with this, and anytime if it's equal I can say that yes, there contains a permutation which returns, which is actually a power of 2, or else after this for loops is over we will say that there is no such permutation. So I think that's pretty much it. This is the Java version of the code, and I think, yeah, thank you for your time.